Hi, welcome to Containerized Deployments for your SPA and API. This is a really fun talk, and the slides and code are online right now. Here's the slides at robrich.org, and the code is available on GitHub. You can grab the link to the GitHub and the slides at robrich.org. Click on Presentations. Let's dive in. Containerized Deployments for your SPA and API. So, how do I deploy my app? When we're looking at a SPA and an API, oftentimes our tutorials will get us to the point where we have two containers, but then what? Let's take a look at the pieces. A single page application. It's great because it's kind of a thick client in the browser. It gives us really fast page refreshes, really fast user interaction. And by separating that from the API, we get a really robust API surface that we can use for not just the website, but maybe other things too. The API could be a JSON or a GraphQL service, and it can be used by lots of form factors. So now that we have that separation between UI and API, well, that's really cool. We get operational and development efficiency, but we also get system complexity. We now have two pieces. Well, how do we host these two pieces? Let's put them in Docker. So when we're inside of Docker, we'll do lots of things very differently. But in our local development environment, we'll have a system kind of like this. The browser will hit our SPA, and inside our SPA in our Webpack config or in our View config, we'll forward API requests off to API. We can take a look at the code and see that here. So here I have a backend API, and it does all the things, and then I have a front-end View app, and here in View config, here's my dev server setup where anything going to API will get forwarded off to my backend. That's perfect. We'll use that a little bit as we get into containers, but in local development, when we're developing outside of containers, that just works. Great. So ordinarily, I would scaffold and build out all of these things, but let's take a look instead, for time, at the Docker files that we'll build for each piece. So first off, in our front end, in our back end, we will have this Docker file. Now this happens to be an ASP.NET site, but you could use a similar mechanism anywhere. Here in the Docker file, we have the steps to copy in our manifest, to restore our libraries, to build all of our content, to publish that content into a dist folder. Now that dist folder is the content that we would need to copy to a web server. Let's create a second container here that is our web server, and now we'll copy that content into place. We used a multi-stage build here so that our source code didn't leak into our production runtime. Now this image is a lot smaller than it would be ordinarily. On our front end, we have a similar type of experience. Here's the Docker file for our front end. Now in our front end, we have View, and so we'll have a node, we'll do a package install, our npm install from our package JSON, and then copy in everything else to use our Docker layers more effectively. Then we'll use npm run build. npm run build will create our bundle package that we can deploy to any static server. Well, let's create a static server, in this case Nginx. We don't need a node runtime anymore. Here in Nginx, we'll copy in an Nginx conf that will just return our index.html instead of a 404 page, so that if we have any other routes, they'll boot up our SPA too. Now we'll copy in all of the built content from our other image, and now we have a SPA ready to go. So this is great. If we have these two apps, now let's launch them. So we'll start off and we'll say, let's Docker run on port 5000 our API. Let's also Docker run our SPA app on port 3000. And now if I come to my API, I can go to localhost 5000/API, weather forecast, and I can see some fake weather data. Perfect. My API is working great. As I come here into the front end, I'll hit port 3000, and now we have this View app that is not that different than any View app. It's going to do some interesting things, though, to call into our backend API. Let's take a look at that controller. So here in this component, we have a weather forecast component that is going to go call into /API/weather forecast and go grab the data to be able to display on the page. Now, if it has an error, it's going to grab that and set it in exception. So here we have an exception. We have the row.temperature, row.summary, row.date format looping through each of those things. So we have that mechanism to be able to bind those pieces. Let's refresh this and see why we're getting this error. Coming back to network, and we see that it did a first request that got us our initial page, and then it did the weather forecast request. Well, it did the weather forecast to localhost 3000/API/weather forecast. Now we know that on 3000/API/weather forecast, there is nothing. Well, rather, it's going to load our homepage. We need to get to port 5000. Now in development, we do have that view config.js that will proxy things into place, but here in our production runtime, we don't have that mechanism in place. In our production runtime, we just have static files, and so they're running in different places. Let's kill off these two containers. Docker container rm-f, and now we're ready to go. So that's the magic sauce is, well, where do we run the things? Do we run one container or two containers? Do we run on one domain or two domains? Maybe a main domain and a subdomain like api.mysite.com. How do we get from here to there? Let's take a look at each of these mechanisms, and they aren't mutually exclusive, and see where we can go. Well, if we run two containers, we could run the two containers on a single domain or on subdomains. One container, we can only run one container in one place. But let's look at each of these pieces and see how to run them inside of Docker. Ultimately, we'll look at, well, which one should I choose? Or asking better, what are the pros and cons of each choice? And when should I choose each one? Docker architecture design. When we're looking at one container, one domain, we'll have our browser reach through the internet to both the SPA and the API running in one place. Let's take a look at that Docker file. Here in one container, one domain, we have a Docker file in the root of our project that is going to do all the things for both places. We start off and we do our .NET build. Here's building our .NET app and all of the steps that we saw in our backend API. Next, we're going to build our Vue app. We saw this in our front-end API. The next step then is to copy from build.net into dist and copy from build Vue into app www.root. Now, app www.root is that folder where .NET will serve static files. Well, we do need to tell .NET how to serve static files. So, for example, we have in startup.cs, we do have some extra things. Use default files and use static files. We need to add that to our API because normally it wouldn't do this. Okay, now we have one big Docker file that will grab both pieces and use our API to host our static files. Perfect. So our browser will hit the internet, and this one big container has both the SPA and the API pieces in it. We modify our API to be able to host static resources, and everything works great. The one additional piece is that we do need a controller that will listen on everything and serve our index.html file, much like the nginx config file did. Okay, so in dev, we're going to continue using our Webpack dev server mechanism, where the browser goes to the SPA and the SPA forwards off to the API. But when we build in production, we're going to build that one big container so that it can live in one place. Great. So when would I use this? Well, I would use it when I wanted to deploy to a single hosting account. If I have a monolith that has a SPA in front of it. If I only have one Netlify account or one Amazon web app. At that point, I want to put it in one container and I want to host that one container in place. That's a great mechanism to be able to host a single thing. Well, how would I host two containers on two different domains? Well, in this case, the browser is going to reach through the internet to the SPA and pull back those things. And then the browser will reach through the internet to api.example.com to be able to run that piece. Now, it does take a lot to make this happen because we're making cross-site requests. The API has to have a whitelist of allowed domains. The SPA has to know what that foreign API is. And as the SPA starts to make an AJAX request, the browser actually intercepts that and makes an options request, not a head or a get or a post or a put. It makes an options request. And what it's looking for in that options request is this CORS header, access control allow origin. And it's going to get a list of domains. It's going to compare that to its current domain and know if it can make the request. If the browser finds a match, then it will continue on with the regular get or post request and send that off to the API. So there's a lot involved in making this happen. When we have our container, we have various pieces in 2 containers, 2 domains that we need to put in place. In our startup.cs, we have to add all of the CORS details. So in this case, we're not only doing CORS here, but we're doing it here. We also have some configuration of what is that CORS domain. Here's that app settings.json. In this case, it's a star, where we can specify the CORS domain. In our Docker file, we'll set that CORS domain as well so that we can get those details into place. In our front end, we need to customize the component to be able to specify that front end domain. No longer are we just calling /API/weather forecast, but rather we need to put in that base URL in front of it. Now, one of the rules of Vue for environment variables is it will bake in anything that starts with view_app. So in this case, I have view_app base URL, and now I can get from here to there. Now that does mean that I need a .env.local and a .env for each environment, and they're, well, baked into each file. So once I've got that ready to go, let's spin up these 2 containers. So let's run our backend API. Now we did have to build it specific to each environment so that we get the correct environment variables baked into place. We'll run our front end API. And now we've got those 2 running. One is running on port 5000, one on port 3000. Let's come in here to localhost 3000. And we'll load up our application. Ooh, we got weather this time. Let's take a look at that request. So we did go to localhost 5000 when we made that request. We have the environment variable baked into the front end API. We have the CORS header in the back end API. And so ultimately that solution worked. But there was a lot of complexity involved in creating this container in this CORS header. On the upside, we can scale this process separately. Maybe we have 2 different teams working on each side of it. On the downside, we added a lot of complexity with these CORS headers. We can't take our images between environments because those environment variables are baked into the image. They have to be because the Vue app is running, well, in the browser. We don't even have server-side environment variables we can inject in at runtime. They have to be baked in at build time. When would I use this approach? When I have very separate teams that need to accomplish both processes. That's when I'll do this task. Let's look at 2 containers, 1 domain. We'll start off by stopping these 2. Docker container stop. Okay, taking a look at the code for the 2 containers, 1 domain, we have our regular Docker files. We don't have any CORS details in our application. We're free from all of the use static pieces, all of the CORS pieces. In our front-end application as well, the Docker file is completely unaware that we're about to run them on 1 domain. The magic sauce here is in our Kubernetes YAML file. So here in our Kubernetes YAML file, we're going to specify the deployment for Kubernetes. And so here's our backend deployment. We also have a backend service. We'll have a front-end deployment and a front-end service. All of these are completely unaware that they're about to start both pieces on a single domain. The Kubernetes ingress controller is the magic that makes this work. If I have anything that starts with API, I'm going to forward it off to this service. Otherwise, I'm going to forward it off to this service. Looking at how this works, we have a browser that forwards through the internet into this Kubernetes ingress controller. The ingress controller decides, should I send it to the SPA container or to the API container? Kubernetes ingress controllers are baked into Kubernetes, and so this works really, really well. We have those two containers running, and we have the Kubernetes ingress in front of it making that happen. So let's come into here, 2 containers, 1 domain, and let's run it. kubectl apply-f kdes, and kdes will actually run through all of the files in that folder, applying all of those into Kubernetes. kubectl config get kubectl get ingress and everything else. I see that all of my pieces are running. And now if I hit mini localhost on port 80, I will get to that ingress controller. Now this ingress controller is standing in front of both containers. You notice that I got the initial request to localhost, and I went to go get the weather forecast also on localhost. The browser doesn't realize there's any difference. The ingress controller is the one that stands in the way and says, should I forward it off to the SPA or to the API? Kubernetes ingress controllers are a really elegant mechanism to be able to stand between these two pieces and do what we need to do. In development, we're still going to use Webpack Dev Server to send everything through the SPA and forward API requests off to the API. We take a look at the Kubernetes ingress controller and how that works. That's really elegant. This solution is really great when I want to be able to remove all of that complexity of CORS headers, and I want to be able to deploy in an environment where I have Kubernetes. I can scale each side independently. I can put more weight behind the backend API and serve the static resources maybe on a very lean mechanism. On the downside, ingress is a function of Kubernetes, and so I need a Kubernetes environment to be able to run this. Kubernetes is a little bit intense to manage, and so, well, it's not going to run on my Netlify account. But if I have lots of microservices and I need to host a lot of things, then this is a really elegant technique to be able to remove some of that complexity into my application and host all of the pieces in one place. So as we look at deploying mechanisms, we can deploy a single domain or subdomains. We can deploy 2 containers or 1 container. If we're going to deploy 1 container on a single domain, we'll put our SPA in the API's public folder. In this case, in our www root folder. And at that point, then 1 container can run on a single domain. We'll use this in Netlify. If I have 2 containers running on a single domain, I'll use a Kubernetes ingress controller. Kubernetes ingress is really great at being able to direct traffic between 2 different pieces. If I want to run 2 containers on 2 different domains, then I'll add a base URL and CORS headers. That's decently involved. So which solution is the best? Well, it depends a lot on your environment. If you're going to run 1 container on a single domain, that's great when you have few microservices. Maybe you're running in a shared hosting like an Azure Web App. If you have 2 containers on a single domain, you need a Kubernetes environment. It's great for simplifying your application, but if you're running on a different orchestrator, then, well, you need to use a different solution. If you're running 2 containers on lots of subdomains, then you'll have some additional complexity in your environment, but this is great when you have very different teams working on different projects, and they can agree on a very consistent interface between them. This has been a lot of fun being able to share with you building your SPA and API inside Docker. Find me in that spot where the conference has designated Q&A, or hit me up on Twitter at Rob_Rich. This has been great. Thanks.